Hey class, this question is from AP Chemistry Chapter 3 homework, stoichiometry. We're looking at number 32. It says hydrogen cyanide is produced using this chemical reaction. It tells us what it's made of, and then it gives us some information about what we have available. I have 5.00 times 10 to the third kilograms of each, and these are what we have in H3O2 CH4. So every reactant we have the same amount of 5.00 times 10 to the third kilograms. Now if I have that many kilograms, we got to figure out how many grams that would be. So what I want you to remember is that a kilogram, 1 kilogram, is 1,000 grams. So whatever this number is, we got to multiply it by 1,000. So if we wanted to do that in our calculator, we could do 5.00 times 10 to the third. But then I want to multiply it by 1,000. It's going to give me this huge number. If I want that in scientific notation, I quickly hit the mode button, go over to scientific notation, enter second, and then quit. Enter again, and I get 5 times 10 to the 6th, but we want to keep those 0.00, 5.00 times 10 to the 6th kilograms. So this number here is also known as 5.00 times 10 to the 6th grams. I said kilograms, I meant grams. Okay, so that's something that as we go through the year, you're going to want to be able to do that in your head, but just so that you know, that's the thought process behind it. Okay, they're reacted. What mass of HCN and of H2O will be produced, assuming that we have 100% yield? Assuming 100% yield just tells me that I don't have to worry about percent yield. What 100% yield means is I'm going to make exactly what I expect to make. So we're just going to do some stoichiometry. Start out with this number, 5.00 times 10 to the 6th grams of, and let's start with NH3. I'm going to have 1 mole NH3. And then how many grams of NH3 would that be? Well, if I look at my periodic table, I can figure that out. I think we're getting good enough at molar mass. I'm just going to do that, and then I'll write it in. So our molar mass for NH3 looks like it's 17.031 grams. Okay, and I can calculate that and find it. I'm going to run out of space up here to do all of the things that I need to do, so I'm going to do the next couple of them down here. So I also have 5.00 times 10 to the 6th grams of O2. I should have probably planned that a little better before I got started, but I didn't, so we're just going to go with it. Okay, grams of O2, it's about 31.998. Grams in 1 mole of O2. And then the last mass is for CH4, and it's 16.043. So we're going to start again with 5.00 times 10 to the 6th grams of CH4. One mole CH4. And then I get over 16.043. And your numbers might be slightly different depending on which periodic table you use. It's fine if they're close. Okay. And then we want to just put this in the calculator. 5 5.00 times 10 to the 6th times 1 over 17.031. I get this huge number, and I don't really want to write that all down, so I'm going to change it to scientific notation. But, all right, I get this times 10 to the 5th. I need 3 sig figs, so I'm going to say 2.94 times 10 to the 5th moles of NH3. I'm going to write that right here. 2.94 times 10 to the 5th moles. And then I have 2 moles on the bottom. Okay. Keep going on that. Doing oxygen now. 5 times 10 to the 6th times 1 over 31.998. See if I mistyped. I made a video earlier and I didn't check my typing. Excuse that phone call. Okay, 1.56 times 10 to the 5th. Moles of O2. And we can write that up here. 1.56 times 10 to the 5th. Put a 3 down here. And by the way, that would be moles. This is moles. Okay. And then finally, CH4 is going to give us 5.00 times 10 to the 6th times 1 over 16.043. We get 3.12 times 10 to the 5th. 3.12 times 10 to the 5th, and that's moles of CH4. So up here I'm going to write 3.12 times 10 to the 5th moles. 3.12 times 10 to the 5th moles. Okay. So we've got our setup. This is a limiting reactant problem that we're going to have to do 3 of them, okay? Because we have 3 reactants. So I'm going to do all of that over here. I've got 2.94 times 10 to the 5th moles of NH3 over 2 moles of NH3 okay, then I'm going to have 1.56 times 10 to the 5th moles of O2 over 3 moles of O2 okay. And then I've got one more I'm going to do right down here, which is 3.12 times 10 to the 5th moles of CH4 over, I made a big silly mistake right here. This is not what I should write here, is it? I should write 2 moles on the bottom. 2 moles of CH4. At least I caught it before I wrote it again. So your numbers on the bottom always come from the coefficients in the equation. Okay. And now let's do some calculating. And we want to compare these answers. We don't need to set up a proportion yet. We just want to find out which one gives us the smallest number of batches. So 2.94 times 10 to the 5th over 2. 1.47 times 10 to the 5th. No units needed. Okay, now I have 1.56 times 10 to the 5th over 3 We get 5.2, keep it 3 sig figs, we're going to say 5.20 times 10 to the 5th, no units, 3.12 times 10 to the 5th over 2, and I'm going to get 1.56 times 10 to the 5th. All right, so there we are. Which of these is the smallest? Well, they're all times 10 to the 5th, so that makes it not too bad. Okay, I just have to pick which of these numbers is the smallest, and it looks like it's this one, right? So this is my limiting reactant. Okay, now let's go over here, and I'm going to switch color again. You know what, let's do yet another color. Let's do brown. All right, I'm going to take that one, 2.94 times 10 to the 5th moles of NH3, since that's my limit, or yeah, NH3, that's my limiting reactant, so that's going to tell me how many moles I get out of whatever I'm looking for. Well, I've got to do this twice, so I'm going to start by finding moles of HCN, and then I'll find moles of H2O. Right? So then HCN is going to be X moles over 2 moles. Of course, I want to find grams in the end, but right now all I can do is moles. So I'm going to say X moles of HCN over 2 moles HCN. Okay, cross multiply, we get 2x equals 2.94 times 10 to the 5th times 2. So let's set that up. 2 times x equals 2 times 2.94 times 10 to the 5th. Okay, I see right now I could just get rid of that 2. I'm going to cancel it out because it's on both sides. It's the easiest way to do this. So x equals 2.94 times 10 to the 5th moles of HCN. I'm going to leave just a little bit of space because we got to turn that into grams. Now let's go to the other one. So starting with the same number of moles of NH3, 2.94 times 10 to the 5th moles of NH3 over 2 moles of NH3. Because remember, I still have the same amount of the limiting reactant. I'm just looking for something else this time. I've got X moles of H2O over 6 moles of H2O, because I'm looking for H2O now. Okay, cross multiply, I got 2x, 2 times x equals 6 times 2.94 times 10 to the 5th. Okay, now you could do this in a calculator, or if you wanted to, you could cancel out and say, okay, get rid of the 2, and this is going to become a 3, right? But if you'd rather, we can just do this. X equals 6 times 2.94. See, I'm going to divide by 2 on both sides so that I can get rid of it. 6 times 2.94 times 10 to the 5th over 2. And let's find out what that equals when I put that in the calculator. 6 times 2.94 times 10 to the 5th divided by 2, and I get 8.82 times 10 to the 5th. Moles of H2O. Okay, now we need to turn it into grams. We need to do that for both of these. Okay, I just ran and got some white out because some of the typos were bothering me. You got 2 moles right there, and then we're just going to find the number of grams down here. So we start out by putting 2.94 times 10 to the 5th moles of HCN. Multiply, and of course because we have moles here, we need to put 1 mole of HCN on the bottom this time. And then on the top we're going to put grams of HCN. Right here we need to put the molar mass, so let me go ahead and find that and put it in. Okay, we get about 27.026 grams of HCN. We can multiply that out on a calculator. 2.94 times 10 to the 5th, 3 sig figs, this is more than 3, so times 27.026 divided by 1, and we get that big old number. I want to round it to 3 significant figures, so 794, and then I've got 4 zeros, so that's actually going to be, and that rounds up to 5, so it's going to be 7,950,000. 7,950,000, right? Yes. And it is grams of HCN. All right, down here, don't have a whole lot of room to work, but we can pull it off. Okay, so we're going to put our 8.82 times 10 to the 5th moles of H2O. Now realize I covered up some of what I wrote there with this. This is H2O. Okay. And then we multiply by a fraction. And on the bottom we're going to have 1 mole H2O. On the top we're going to have the mass of H2O, which is about 18, I believe. 16 plus 1. So it's 18.016, something close to that, 1.008 times 2 plus 15.999. 18.015 or 18.016, depending on which periodic table you ask. Okay. Put that in a calculator. 8.82 times 10 to the 5th times 18.015. I get, wow, that's a huge number. I'm just going to switch it to scientific notation. And you can do that anytime you want to. 1.59 times 10 to the 7th. 1.59 times 10 to the 7th. And that is grams of H2O. And there are your answers for number 32 on Summer Homework Chapter 3.